All right, so we have another combustion reaction here. This time you'll notice the reactant C6H12O6 is not a hydrocarbon. This because it's got oxygen present in it is possibly a carbohydrate. And whenever we have carbon, hydrogen, and oxygen, it could be, of course, some other functional group as well. Carbohydrates are basically sugars. But if there's a CHNO, just label it as a carbohydrate, even though it could be a ketone or an aldehyde or any of those functional groups that you guys have learned about. CHNO, call it a carbohydrate. All right, we're going to do the same thing we've been doing. CHNO. Carbohydrates, just like hydrocarbons, combust. And as they combust, they burn. And as they burn, they need oxygen. So you're always going to have oxygen as the other reactant. And you're going to form, yet again, the same two products, carbon dioxide and water. Will there be anything else? No. Carbon dioxide and water. All right, so we got 6 carbons, 12 hydrogens, and we got 6 and 2 is 8 oxygens. Now on the product side, 1 carbon, 2 hydrogens, 3 oxygens. Okay, business as usual. Pick your battles. Carbon would be nice to balance. Put a 6 here. By doing so, the carbon becomes a 6, and we got to change, of course, the oxygen tally. We have 6 times 2 is 12, plus 1 is 13. Okay, from there we move on to the hydrogen. Hydrogen is 12 and 2 on the other side. Put a 6 here. That'll make the hydrogen 12. And the oxygen is now 6 times 2 is 12, plus 6 is 18. Okay, now we have a little problem. We have 6 and 2, and we want to get 18. How are we going to do that? Very easy. Because you can't change this formula, it has to be left alone. What you're going to do is look at the target number that you're trying to get, because the carbon and the hydrogen are perfect. You can't do anything better. So you want to make this 18 as well. So how are you going to do that when you have this formula and that formula to work with? What you're going to do is you're going to match the 18. And because you can't change this formula, you're going to take away those 6 oxygens that are etched in that formula that cannot be moved or altered away from the total target number 18. When you do that, you're going to be left with, what is this? 12. 12. What you're going to do is make up the difference. So in order for you to get 12 more oxygens, you're going to put a 6 in front of the O2. So now you have 6 times 2 is 12, plus 6 is 18. So that's how you do reactions like that. Once again, match the number that you're trying to target, deduct from it the number of oxygens in the carbohydrate that you cannot change or alter from that number, and then the difference you'll make up with the oxygen molecule. So you have now the balanced reaction for this equation.